Hello everyone, welcome back to a quick bites video of Bites of CC. So today we will learn about heap sort. So in my previous lecture I've already talked about binary heap. So this is going to be like a continuation of the previous video. So how does actually a heap sort work? So definitely you'll be given a number of elements to sort in ascending or descending order. So if you have to sort that in descending order, you will be creating a max heap out of those elements. And if it is in an ascending order that you have to sort, you will be creating a mean heap. Next, the root will be retrieved, and this will go on in a for loop till the last valid elements in the tree. And what you will get after popping those elements, like deleting the root, is a numbers in ascending or descending order. So there are basically three operations involved. First, you will need to create the heap. Next, you will need to delete the root, or in other words, you might say that you will need to extract the maximum or the minimum element of the elements in like currently in that heap, and then you will have to adjust the heap, like the heapify operation, if you remember. So you will have to do the heapify operation to preserve the heap property. So now let's take an example to see that how it really works. So you are given a number of elements like this. These are an array of integers, and now you are asked to arrange that in descending order. So naturally you will have to convert that to a max heap. So I'm not going to repeat how this max heap is created from an array of numbers. So I'll highly recommend you to go through my video, my last video, if you don't already know that. So when we rearrange, when we create the max heap, the rearranged array looks like this, and when we create a binary tree out of it, it looks like this. So this is basically the algorithm that we used in our previous video to build the heap. So I have also used the same algorithm basically to create this heap. So I'll just ask you to go through that video, because it's shown step by step in that video how to convert an array to a heap. So this is what your heap looks like now, and now you have to arrange that in descending order. So the first step is to delete the root. So since this is a smaller operation, I'll be walking you through deletion, though this is also covered in that video. So the first element, that is the first index, that is the root, will be exchanged with the last index, in this case node number, the node that contains number 9, and this is how the heap will look like. And then you will just pop this last index off. Okay, and the heap now looks like this. Next, you'll be starting with the max heapify operation. So as discussed, 9 will be compared to 49 and 35, and 49 being the maximum among the three, 9 will exchange its position with 49, and finally 9 comes here, and again 9 will be compared to 24 and 17, and since 24 is the largest among the three, 24 will be shifted at this position and 9 will be shifted at this position, and this is how the tree is going to look like. And the popped element, suppose you have a data structure that holds a popped element. Your popped element will contain this value 83. The next element to be popped will be 49. So now 49 is the root, and this is the last index. So 49 and 12 will be exchanged. So 12 will come at this position, 49 will be here, and finally 49 will be cut off from this position, and the heap is going to look like this. So again, as per the previous discussion, so 12 will exchange position with 35. So 12 will come over here and 35 goes up at this position, and then since 12 is greater than 5, 12 stays here, and so 49 comes here since 49 has already been deleted, and this is what the tree looks like. From now on, I will not be repeating this again. So next element to be popped will be 35. So after popping 35 and making all doing the max heapify, this is how the tree, the heap is going to look like. And the next element to be deleted will be 24. So 24 comes over here, and the tree now looks like this. And now 17 needs to be deleted. 17 is popped and the tree looks like this. And then 12 is deleted and the tree looks like this. So I will highly recommend you to take a screenshot of this and just try out this max hippify thing. And if you just find any problem with this, just let me know about it in the comments, okay? And finally 9 and 5 will be deleted. So this is an array of numbers where the numbers are arranged in descending order. So now let's look at the runtime complexity of heap sort. Now a heap sort algorithm looks like this. So first you will build, so since this was a max heap, I think it will be more appropriate if I just move this max heap. So you will just build the heap and then you will again heapify it. So as I said, in case of min heap, you will just have to exchange, like it is less than this, so this will just be greater than, so this less than will be exchanged to greater than. So now as we said, as we knew, this build heap operation takes on time, and this heapify operation, oh just a moment, this is going to be a0. I just made a mistake. This is going to be a0. So my indexing in this case also starts from 0. So this operation is going to take like O log n time. Okay. Suppose there are n elements to be sorted, and now this array, the for loop, runs for n minus 2 times. Now, when we are using asymptotic complexity, what we do is we try to find out the growth of the algorithm when n approaches infinity. So what happens here is n minus 2, when n approaches infinity, when n is almost equivalent to infinity, so infinity minus any finite number is also equivalent to infinity. So n minus 2 is also equivalent to, almost equivalent to infinity. Okay, so so we assume that the loop is actually it is running for n times. So since the loop is running for n times, and for n times heapify operation is taking place, therefore what happens here is this portion, like for this portion, the complexity is going to be O n log n, that is n times log n operation is happening. Now this entire heap sort will take a time of on, that is for building the heap, plus O n log n. Okay, now as we approach infinity, here also we need to remember that. So infinity plus infinity is also infinity, right? Now what we do is we try to find out which is the bigger of the two. Now n log n is greater than n, so therefore we will say that the runtime complexity is O n log n in case of heap sort. So that's all for today. Thank you for watching.